So the unit circle is a circle. It has a radius of 1. It's centered at the origin. And like we said just a second ago, that we can use our ratios that we used the other day, our y over r, x over r, our r over x, to figure out what our sine, cosine, tangent would be for our unit circle, because our radius is going to be 1. So we're just going to plug that in for our r value. So if you are looking on the unit circle and you wanted to figure out what the sine value was, the sine value is simply the y value in your ordered pair. Because before we said it was y over r is 1, so that would just leave us with y. The cosine, we're plugging 1 in for that r, x over 1, same thing as just x. Tangent in our other one with our terminal points was y over x. There weren't any r's in there, so this is also just going to be y over x. Nothing for us to change. So if you have an ordered pair from your unit circle and you want the tangent, we're simply going to divide the y value by the x value. To get your cosecant, just like we've done before, we're going to flip over our y value. So we can write it as the reciprocal, 1 over y, or just think about it as flip the y over. So if your y value was a half, you'd flip it over and it would become 2. If your y value was root 3 over 2, you'd flip it over, it'd be 2 over root 3. Same thing with secant. Secant you can think of as 1 over x, the reciprocal, or simply flip the x over. If the x or the y was a whole number, just make sure you put a 1 underneath it before you flip. And then cotangent, how would you flip over y over x? X over y, yeah. So if we have these ordered pairs from our unit circle, which you'll just look on your unit circle and find them, you can follow this guideline. You know the sine is y, the cosine is x, the tangent is y over x. And then flip them to get your cosecant, secant, and cotangent. Remember when we were looking at that triangle, we said that using the Pythagorean theorem that x squared plus y squared equals r squared. We made our triangle. We said the two bases squared is r squared. Well, we can plug in what these things are from our unit circle. Our x is our sine, our cosine, our y is our sine, and what is the radius in the unit circle? That is just 1. So we can replace these. And we've got cosine squared plus sine squared. It's going to equal 1 squared, or just 1. But I'll put squared there. So this does come up a lot. This is called a Pythagorean identity. Where if you square sine and cosine both, add them together, you should get 1 if it is on the unit circle. That's a way to test if it's on there. I don't think I put any of those in the homework, but just in case you ran across that somewhere, you knew one of them, you could use the Pythagorean theorem to find the other. Okay. All right, are you guys ready to actually use it to find some of our answers, like what you'll be doing in your homework? You ready for that? Okay. So we're going to do some that are negative angles, positive angles, some sine, cosine, secant, all that jazz. And then we have one other type of problem to do, which you've kind of already done, but I want to make sure it's all clear before you start working on your homework. So I'm going to write some down that we're going to use our unit circle for. I didn't mean to write two negatives right there. This last one is just secant of negative 5 pi over 4. What's the button to split your screen? Like to split to make two screens? Y'all remember? Like you hit something, something, and then it makes you have two. Oh, it's arrow over. Something in the arrow over, maybe? Whatever. I'll make it smaller. I'll just put them both up there together. We'll see. Y'all know what I'm saying? Oh, you make it smaller. Okay. There's something that locks them into place. I wish I could close this thing down in the PDF. And have a 7-day free trial. Okay, it's gonna have to be a little bit miniature. All right, so let's go through and see what we need to do to figure these out. So the first one we said sine of pi over 4. So go to pi over 4. Is sine the x or the y? Sine is the y. Cosine is x. Sine is y. X comes before y in the alphabet. Cosine comes before sine in the alphabet. That's how I always remember it. Okay? X, y, cosine, sine. All right. So sine is the y value. What is the y value at pi over 4? You guys see that that is root 2 over 2? So we're going to write down root 2 over 2 for sine of pi over 4, and that's going to be our answer for that problem. Okay? Everybody okay on the first one? Sine was y. We just found the y at root 2 over at pi over 4. Okay, go ahead and find 2 pi over 3. So find 2 pi over 3. That's 120 degrees. Cosine, is that x or y? 120 . 120 . 120 . 120 . 120 . 120 . 120 . 120 . 120 . 120 . 120 . 120 . 120 . 120 . 120 . 120 . 120 . 120 . 120 . 120 . 120 . 120 . 120 . 120 . 120 . 120 . 120 . 120 . 120 . 120 . 120 . 120 . 120 . 120 . 120 . 120 . 120 . 120 . 120 . 120 . 120 . 120 . 120 . 120 . 120 . 120 . 120 . 120 . 120 . 120 . 120 . 120 . 120 . 120 . 120 . 120 . 120 . 120 . 120 . 120 . 120 . 120 . 120 . 120 . 120 . 120 . 120 . 120 . 120 . 120 . 120 . 120 . 120 . 120 . 120 . 120 . cosine. Cosine is the x. So what is the x at 2 pi over 3? Negative 1/2. So we'll write down negative 1/2. I'm going to put that right here just so we can see it. That this is cosine is the x, sine is the y, just as a reminder. Okay. All right, tangent of 4 pi over 3. Tangent is your y value divided by your x value. So go to 4 pi over 3. The y value is negative root 3 over 2. The x value is negative 1/2, and we're going to divide those. So y divided by the x. And I'm going to show you a trick that works for tangent every time that they're divided by 2. We've got negative root 3 over 2 divided by negative 1/2. Remember, when you're dividing a fraction, you flip the second and you multiply. Okay, so we're going to write that out. I'll just make sure everybody's clear about that. So this is like negative root 3 over 2 times negative 2 over 1. Remember, we flipped the second fraction. What's going to happen with our 2's? They're going to cancel out, and a negative times a negative makes a positive. So our answer for this is just going to equal positive root 3. 2's cancel. Root 3 over 1 is just root 3. Okay. And when you are looking at the fraction ones, all of the ones that are divided by 2, and you're doing sine and cosine, when they have the same denominator and you divide them, those denominators are going to always cancel out. Does that make sense? If you were going to flip it, they would always go away. So when your denominators are the same, you can just, at this point here, cancel them out if your denominators match. Not your numerators, just your denominators. And then you just look at this number over that number. Okay, so negative root 3 over negative 1 is just root 3. So anytime I'm doing tangent, I don't ever write them down like this. I just look at numerator over numerator because I know the denominators are going to cancel. All right. What is our next one that we have? Sine of pi over 2. We have not done the pi over 2's or the pi's yet. So that there were some of those on your homework on accident. But pi over 2, that is 90 degrees. So we're going to go to 90 degrees. What is the sine value? Everybody hold up their fingers. Is it going to be 0 or 1 for the sine? So I need 0 or 1 for the sine. It's going to be 1, right? Because sine is the y. Okay. Cosine is the x. Sine is the y. What is it, Alan? Sine is the y.
I was looking at, wait. All I heard was the, I know it's the X and the Y, but
Okay.
I had picked the wrong.
Oh, you looked at the wrong one. Gotcha. You were looking at over here probably. Yeah, pi over 2, not 2 pi. That could have been it. So our sine of pi over 2 is 1. All right, now let's do cosecant 5 pi over 3. Find 5 pi over 3. Right here, right? To get cosecant, what do you flip over to get cosecant? You flip over sine, which is the y, right?
The y.
Yeah, we're going to flip the y over. So the y was negative root 3 over 2. So instead, we're going to flip that. And it's going to be negative 2 over root 3. So we flipped over the sign. So what do you think we need to do to deal with this? Our root 3 on top and bottom. So it's negative 2 root 3 over 3. That's really sloppy looking, sorry. So remember, we're getting the exact same answers as if you had done it the way we did before with the triangles. So if you like doing it with the triangles better, that's perfectly fine. You just can't get like the 90 and 180 and stuff. Cotangent of 300, cotangent of 300. So cotangent is x over y. So let's see what our x and y are on 300 degrees.
Is it square root of 3 over 3?
Let me see. So, oh no, I pushed the wrong button. Gonna mess up. So 300 is going to be x over y. So 1 over negative root 3. I mean, you also have your 2's, but your 2's will cancel, right? We said they'll cancel. So 1 over negative root 3. And then you have to do your root 3 over 3. Root 3 over root 3. So you're right, Nick, except you need a negative in the front. So negative root 3 over 3. So with your cotangents and tangents, remember when you're dividing those denominators, when they match, they're going to cancel out. So I just looked at the numerator of the x and the numerator of the y. It's x over y. Thumbs up if this is okay so far. Finding your x, finding your y, flipping stuff. Okay. All right. So now we have some negative angles. I just want to make sure that you're good with the negative ones. So if I have negative pi over 6, what I always do is I always see what pi over 6 is just in degrees, because negative radians kind of make me a little like, not really sure exactly where that goes. I want to see where it is in degrees, and then I'll just backtrack that much. So pi over 6 is 30 degrees. So negative 30 means I'm going to go from the x-axis here, go backwards 30 degrees, and wouldn't I land here at 330? So I would just write down whatever it was for where the 330 is. So it said negative pi over 6. Pi over 6 is 30. I'm going backwards 30, and that would get me here. I don't even remember what I asked you to do on that one, though. Which one was it? Oh, cosine? Okay. So cosine is at the x or the y?
X.
The x, so that's the root 3 over 2. Right, and then the last one was negative 5 pi over 4, secant of that. So let's see what 5 pi over 4 is. I think it's 225. So 5 pi over 4 is 225, okay? But I wanted negative 225. 360 minus 225, that actually is 135. So if you subtracted it, you would get to 135. Everybody okay with that? That's 225. So backwards that much would be here. So I'm at the 3 pi over 4. What do you flip over for secant? I'm going to flip the x over. So we had negative root 2 over 2. I'm going to flip that over. Okay, so then I'll multiply by root 2 on top and bottom. Ends up being negative 2 root 2 over 2, and these 2's will cancel here. So your answer is just negative root 2. This is a sloppy mess because I couldn't change the color because my computer would mess up. So negative 5 pi over 4. 5 pi over 4 was 225. So we went backwards 225 and got to 135. Secant is the reverse of cosine. Flipped it over. Had to rationalize it. That one does simplify there. Okay. All right. The very last thing for this section is if they give you one of your trig ratios and then tell you to find the rest of them, they'll also say something that will tell you what quadrant you're in, kind of give you a hint, just so you know if things are positive or negative. Because if you notice on our unit circle, this one does tell us what's positive in which quadrant. But in the first one, x and y are both positive because sine and cosine are both positive. We're in the first quadrant. The second quadrant, Sine is what's positive, cosine's negative. The third one, sine and cosine are both negative. The fourth one, we've got sine that's the negative one in the quadrant. These are problems that are at the end of your homework assignment. There are some of them that just want you to find one trig function and some that want you to find all 6. So I'm just going to make sure that we can do the all 6 kind. Because if you can do all 6, then you can do just one. That's fine. So they'll tell you something like cosine of theta is equal to -4/5. And then they tell you something else like cosine is -4/5 and sine is greater than 0. Sometimes they like specifically already tell you what quadrant you're in, but other times they just give you another clue. And so based on these 2 pieces of information, you have to know what quadrant you're in so that you get the signs right. So that's why they tell you about whether sine's positive or negative. So the first thing on these problems is you figure out what quadrant you're in, then you draw your triangle to find all of your trig ratios. Okay.
You always have to draw the triangle?
Well, you got to find your third side. So you need to know, like, if it was opposite, adjacent, hypotenuse, so you'll know to be able to label it for these. So for us, let's look and see. We're looking when sine is positive and cosine is negative. So what quadrant is sine positive and cosine negative? In the second quadrant, right? Because remember A, S, T, C, that's when sine's positive and cosine's negative. So we have sine is positive because we said greater than 0. And we have cosine being negative because they told us our cosine was negative. So we're in the second quadrant. So that's going to be important for us. So they give us this. We have to figure out which quadrant it is. Then we can write out our stuff. So they give us that cosine is -4/5, right? And I'm going to go ahead and write the signs that I need to have just so I'm not messing up. I'm in the second quadrant. So sine is positive in the second quadrant, and that also tells me that cosecant is. Cosine is negative, so secant is negative. Is tangent negative or positive in the second quadrant?
Negative.
Negative, right? Because it's sine over cosine. So positive over negative makes a negative. So we already have our signs. Those are like half the points on these problems. And now we've just got to figure out the rest of our trig functions, which you guys have already done in problems, but I just wanted you to make sure you got the signs right. So if we have theta here, this is adjacent over hypotenuse, right? Cosine, adjacent over hypotenuse. So 4, 5, because this was adjacent, this was hypotenuse. We do our Pythagorean theorem. And b is going to equal 3, because it's our one that we do all the time, but you could write it out and figure all that out. So this value is 3 that we found for our opposite. Now we just fill it all in. Do y'all need me to fill it in, or you can do it?
Sin is 3/5.
Yeah, sine is 3/5.
Sorry.
That's okay. So sine is 3/5, so cosecant is 5/3. Cosine 4 over 5, so secant is 5 over 4. Also negative, but we already wrote that. Tangent, opposite over adjacent, so 3 over 4. Cotangent, 4 over 3. All right, so the only thing new about this, because y'all already did problems like this before, was just you have to make sure that you know what quadrant you're in. Because they'll tell you at the beginning if cosine or whatever it would give you is positive or negative, and then they give you one other clue. So you have to figure it out from that. Okay.